Check.
The second one.
Section is that.
Down to 100%. I don't know the section, I know it's like a number. Yeah, it's more. Yeah, with this tank. We can figure it out. We look at how to do it.
So, well, what I saw was down, so you've got this level right here, hold that pressure right there,
Should be.
hold that pressure right there. Okay, pressure right here is equal. This was something like that. It's at the bottom, I don't know why, it's the whole oil. And then that's when people to the pressure of the atmosphere goes.
That's very hard to do. Yeah.
Yeah. Okay.
So. Do this, heat goes to this. There.
Okay.
It's a sulfur here. This,
That would always be pressure of the air inside the cage, minus the pressure.
is this a formula?
All right, let's go ahead and get started. If you can hear me, can you say hello in the chat, please? Now we're gonna wrap up 12 point. This is 12.8 today and move into 12.9 and 12.10. If you're in the classroom, chapter 13, 1 through 13.3, the pre-class quiz is in the front of the room. I just realized it wasn't labeled. It's also been uploaded. Okay. You guys have a homework problem or?
Oh, we were talking about it, so no problem.
Oh, okay. So then not this class.
No.
All right. So, let's go ahead and we talked about a sub n, a sub t, right? And we're now going to look at polar coordinates. And one of the things that's going to happen as we move through is we're going to start doing everything in these multiple coordinate systems. So let's just review polar coordinates real quick. So if we look at an XY coordinate system. All right. And we have a dot here. We would refer to that dot as X comma Y. The other way we can refer to the dot in polar is that this length is the radius and this is then theta. So this becomes then R theta. Okay. So I didn't pull down any polar graph paper, but when we have polar graph paper, have you guys seen polar graph paper? I assume yes. Okay. What it looks like is you have a series of concentric circles. All right, and then this is your R value. So this would be 1, 2, and 3. And then you would look at theta. So if I have the point 3 comma 90 degrees, that point would then be there on a polar coordinate graph. Okay, I will put that in the notes. Right, and we can actually move between these two coordinate systems. So, oh, I'll do that. All right. Okay, so if we are looking at a vector in polar, wait a minute, my notes aren't making any sense to me for a moment. Let's wait on that. I guess I'll go ahead and write them down. Okay, so our U vector in terms of R is then going to be cosine theta I plus sine theta J. All right, and I have to assume that since it's a U, it's a unit vector, so then R is going to equal 1. If we have the unit vector of theta, that's going to be then negative sine of theta in the I direction plus cosine of theta in the J direction. Right? Where you're going to see this pop up a lot is when we're looking at our velocity. Our distance up into this point in the class, I guess we have called it R, but primarily we've called it S, correct? So now we're going to have an R vector, and that's going to be the magnitude times our unit vector. All right, so if we then want acceleration, or not acceleration, but polar coordinates, all right, if you think about it, how do we get to velocity? Well, we take the derivative of s with respect to time, and that then gives us our velocity. So now we're going to have r vector dt. Well, that's then going to be our velocity vector, but it's then going to be r hat dr dt. Right? Acceleration, we have to be a little more careful with. By the way, velocity is also going to equal velocity of r And then we're gonna have our R unit vector plus velocity of theta unit vector. All right, acceleration. What are we gonna have to do with acceleration? Because now, what do we need to do? We need to do dv dt. All right, and so we're gonna have d by dt of dr dt r hat. We have to treat this as a using product rule. All right, so,
Mr. Binky,
no, that doesn't work. What?
is that V sub theta just above the word polar?
Yeah.
Okay.
Yeah, that's v sub theta. This one we have to use chain rule on, so you're gonna have r d by dt r hat plus r hat d dr dt.
Only velocity like towards the R direction, like doesn't need the theta component too.
No, it'll need the theta component as well. What's gonna end up happening is let me see if I can move this down. Our V sub R. Yeah, okay. Okay, our V sub R is then gonna be basically R dot. All right, so that's gonna be then the velocity in the R direction.
Okay, so everything you did up there was like sub R.
Yeah. V sub theta though is then going to be R squared theta dot. How theta is then changing with time. All right, now let's back up just for a second and talk about what it means. All right, so R dot is positive. Okay, and that means it's the rate it's moving away from the origin. So if we go back to my silly little sketch, all right, R dot is then telling us how fast this point is moving away, if it's positive. All right, you can probably guess if R dot is negative, how is it moving? It's moving towards the origin. So if R dot comes out to be negative, then it's going to the origin or towards the origin.
It becomes positive, that if it goes through the origin, does it become positive?
Yes.
Okay.
You can kind of think about this in terms of, if you remember back in Calc 1, we just move this. Okay, so back in Calc 1, we were primarily looking to see where things actually went to 0. But you would start with a point. Okay, and then the point would go this way, and then the point would go that way, and then the point, let's say it came back to here. Right, So what did you do in Calc 1? You said, well, here, the velocity has to equal 0, right? Whenever it did that turn, it had to have a velocity of 0. Now what we're saying is when we go through the origin, our velocity is going to be 0. So we go negative, negative, negative. At the origin, the velocity would be 0 because we're at the origin, so we're not moving towards or away. And then it would be positive, positive, positive past that fact. All right, so to address Valerie's question. Okay, so if I have it here and I'm heading towards the origin, which is there, my R is then going to be negative. At this exact, or my R dot will be negative. At that exact point, at the origin, my R dot is then going to be 0 because we're measuring it relative to the origin. Okay, if it goes through the origin and it keeps going, right? So now it's heading this way. Now you're right. Now my R dot is going to be positive. Right. But the velocity, when it goes through that center of polar coordinates, is then going to be 0. That could be a very helpful boundary condition for us. Okay, now theta, or let's talk about what this means. When we are dealing with v theta, all right, I had that listed, I believe, if I wrote it down properly. Oh, it's not squared. Acceleration is squared. No square here. All right, so this is then going to be r theta dot. Now, let's talk about that theta dot because you've dealt with this before, except in the past, you called it angular velocity. Right, and I believe your other textbook uses an omega for it. Is that correct in calc?
Yeah, I think so.
Yeah, all right, but that's our angular velocity. So that's my d theta dt. So that is how fast it's moving around the circle. Okay, so if I have an r of 3, and this is now heading that way, right? Then that's going to be my theta dot, right? How fast is it moving around the circle? So you could see how you'd get some really interesting patterns developing here. Big key is if it wants the magnitude of the velocity and we're dealing with polar coordinates, we do it the same way we've done it all semester. How are we doing, Zoomers? You hanging in there? Yes.
Is that supposed to be r squared theta dot?
No,
Okay.
I made a mistake. The r squared comes in when we're dealing with acceleration.
Oh, okay.
Did you guys all get that correction? All right. All right, are we, let's now talk about acceleration when we are looking at acceleration in our polar coordinate system. All right, so acceleration, we know the acceleration is basically the second derivative, correct? All right, and so we've already learned that acceleration is then gonna be, d by dt. Oh, let's write it this way. Because I think it'll make more sense. All right, so we're gonna do d by dt, right? And then we will then have d by dt of s. So we've been calculating acceleration that way, and your author goes through a very long and involved derivation for it. So I'm gonna let you guys read that. Let's go ahead and just jump to the good part. So this is gonna be a sub r vector that looks like an n. Right, and then we're gonna have a sub theta vector, unit vector. Okay, there's a couple of ways that we can find these. I have it written 2 different ways in my notes, which makes me nervous. So you guys Google it, right? Acceleration and polar coordinates. I'm gonna open the book up. What are you guys seeing? Because as I said, I have it written down 2 different ways, which is why I'm nervous about it. Because I don't want to mislead you. No one's finding it?
I see a bunch of things.
You see a bunch of things? All right,
Like,
so
a sub r is r double dot minus r theta dot squared.
squared, okay, yeah, and that's the thing, and I'm wondering if they're somehow connected. And between when I wrote this up and now, it has fallen out of my brain, because as you guys know, or maybe not,
Yeah, a sub r equals r double dot minus r theta dot squared.
okay, so I have that one written down, so we'll go ahead and go with that one. So a sub r is then r double dot second derivative minus r theta dot squared. All right, I then have a sub theta is then equal, I have it, and you can check me on this, r theta double dot plus 2 r dot theta dot.
That's what I'm seeing too.
That's what you're seeing as well?
The way it's written. Here, so never mind, it just, the way it's written looks confusing, it looks like it's just representing the acceleration of the R vector. It's like a combination of both of those two.
Yeah. All right, and so once again, yeah, see, that's why I was like going, what is happening here? All right, so once again, our acceleration is then gonna be the square root of a sub r squared plus a sub theta squared. You know what, this might be a combination of my notes and Alex's notes, which is maybe why I read the book and then I read Alex's notes and then I got myself turned around. All right, so a sub r, that is our acceleration along the radius. Right, it's also called radial acceleration. So if you see the term radial acceleration, that's what you are looking for. I don't have any notes about whether it's positive or negative as it goes to the axis. I don't think it matters. A sub theta this is then the acceleration of the angle change. So this is how fast it's rotating through the circle. All right. We ready to do a problem? Give me a 6 in the chat if we're ready to do a problem. So, all right, so due to the rotation of a forked rod, the ball travels around the slotted path, a portion of which is in the shape of a cardioid. So cardioid is sort of the heart shape. R equals 0.5, 1 minus cosine theta. Theta is in radians. Ball's velocity is 4 feet per second, and it gives us its acceleration when it's at theta equals 180. And we want to determine the angular velocity and the angular acceleration. So you guys need this bigger, Christopher? No, you're good. Logan, you're in the back. Logan says he's okay. All right, once you have this down in the chat, why don't you give me a 7? Are we ready to get started on this?
Almost.
Almost? Just getting away. So what do we know? Start with what we know and figure out what we can find. So first thing is we know, well, hang on. We want to determine angular velocity, don't we? So if we think about it, we're given the total velocity. So that's going to be that V there. And that's then going to be R dot, well, our V is, let's back up. Our V is then gonna be our V sub R squared plus our V sub theta squared, correct?
Mhm.
V sub R is then going to be R dot squared, right? V sub theta is then going to be R theta dot squared. Okay, I want to figure out this one here, this theta dot, my angular velocity. All right, and I'm given some conditions to be able to do that. First off, I'm told that V equals 4. So this business has to equal 4. And we are told the instant in time that we are interested in. So the instant in time we are interested in is when theta equals 180 degrees. Okay, how can I get R dot? What can we do to get R dot?
Derivative of R with respect to time.
Derivative of R with respect to time. So we're told R equals 0.5, 1 minus the cosine of theta. Okay, so if we then take the derivative of this, I'm going to go ahead and distribute this. Now, to find our R dot, we have to take the derivative of all of this with respect to time. So the first one is a constant, so it's going to be 0. The derivative of a cosine is a negative sign, so that becomes positive. Right? And then here, we're going to have theta dot. All right, so for this equation, that is then where my R dot is. So let's go ahead and plug in, well, okay, hang on, just for a second. We also know theta equals 180 degrees, don't we? That's going to be very helpful because stuff goes away at 180 degrees, doesn't it?
Mhm.
All right, so let's go ahead and see what happens at 180. All right, so my R dot is then 0.5 sine of 180 degrees, right? Theta dot. So help me out here. Sine at 180, 0. Okay, so this is nice because that means my R dot then just equals 0, doesn't it? All right, the second term, our velocity in terms of theta is then going to be R. So we're now looking at this term here. So my R is 0.5, and then it's 1 minus the cosine of theta, right? At 180, all right, what are we going to have? We're going to have 0.5, and then this is going to be 1 minus a negative 1. So that's going to become 2 times 0.5. That ends up being what, 1? Doing math in my head, and that's very dangerous today. What's up, Lorenzo?
That's the answer. Like the readings.
Yes.
He's all we were trying to find.
Huh?
These are these- they're-
Well, we're not actually trying to find radius. We're trying to find, back up, because that's a really good question. We're trying to find our theta dot.
Don't we have like a really simple equation? theta dot. So
Okay, V sub theta does. Right? We're given V, which is our total velocity.
Okay.
Okay,
Yeah.
so looking at this equation, right? What did we just find? We found that this is 0. We know this one is 1. So what is left over? And that is 4 equals then the square root of 1 times theta dot squared. So theta dot is then going to equal 4.
but that's only because we're at like 180 degrees.
Correct. Okay, now I didn't convert it to radians, probably should have, but the answer is then gonna be in radians per second. It wouldn't have made any difference if we had called it pi or if we had called it 180 when we stuck it in. But we want things in terms of radians. Okay, all right. So now let's go ahead and figure out the second half. And so, yes, to answer your question, we're told we have an instant of theta equals 180. So instead of an instant being given to us as time, it's given to us as an angle. All right, so let's go ahead then and find out the angular acceleration. Okay. All right, so what do we know about angular acceleration? Right, well, we know our angular acceleration A is equal to A sub r plus A sub theta. Okay. All right, so our magnitude of the acceleration, which is given to us, is then going to be A sub r squared plus A sub theta squared. All right, and so A sub r is going to equal r double dot minus, is it minus? R theta dot squared. Well, and once again, we are still operating when theta equals 180 degrees or pi. All right, we already figured out what r is. R was 1 at that instant. We also figured out theta dot. Theta dot is 4 at that instant, correct? Okay, but we do need to find the second derivative of r. So r dot was 0.5 sine of theta dot. All right, if we then take the second derivative, right, what are we going to have to use? We're going to have to use product rule. So that's going to be 0.5, and then we're going to have the first, which is cosine of theta times theta dot times theta dot, right? This is my first plus, and then we're going to have the second. So that's going to be 0.5 sine of theta. This is then going to be theta double dot, which is actually what we are looking for, isn't it? How does V equal 4 meters per second becomes radians per second? Because Andrew, I solved for theta dot, and that's how it becomes. It goes from meters per second to radians per second. Yes.
So you did product rule and chain rule or
Yes. Yes. Right, so I did product rule, meaning this is the first,
Uh-huh.
this is the second. There were Rs and other things multiplied in there, they just all went to one or they canceled out for us. Because R is gonna be then meters per radian. Does that make sense, Andrew? I've got some folks checking my calculus in class. Okay, and I probably should have written that out. Can I walk away from this slide just for a moment? So our R. So this became, the R here, is gonna be meters. Hang on, let me think. Meters per radian. Are we working in feet?
Yeah, it's feet.
Okay, so R is gonna be in feet, and that was a straight R, not an R dot, correct? All right, and then this is then going to be, no, because I thought, well, then 4 was feet per second. So then, yeah, then they radians per second. Are you sure we were in feet? We weren't
Yeah,
in meters?
yeah, it's right, yeah.
Yeah, speed.
Okay, so if you look at this, then we have 4 feet equals the square root of 1 foot, feet per second equals the square root of 1 foot radians per second. The feet are gonna cancel. I'll have to think about how that works. Give me a break on that if you wouldn't mind. But I'm thinking this type of development is what we need to do. Okay, so let's go back to where we were here. We know this is all going on when theta equals 180 or pi. Okay, so cosine of, that's gonna be what? That's gonna be -1 times theta dot at this instant in time. We already found that that was 4 times 4. Correct? Plus 0.5 times 0 theta double dot. So that term is gonna go away for us. So this is then gonna equal -8 is then going to be my R double dot.
It's interesting to me that R dot was 0, but we get a value for R double dot.
Okay, so, but our double dot is acceleration. Okay. So it could be passing through the origin, but still have acceleration to keep going. Yes,
So isn't our double dot -8 only when we're at 180 degrees?
correct.
Since the double dot or theta double dot gets canceled out, doesn't that mean that we can't find it?
No, we can, because what's the other, so we have 2 expressions. We have a sub r is this, and then we have the a sub theta. Right? So we figured out, we have basically, we have figured out a sub r, right? We figured out that's gonna be r double dot minus r theta dot squared. So this is -8 minus r we found at 1, theta dot is then 4 squared. All right, so that's gonna equal -24. So if we go back to the equation we were working with, total acceleration is in the square root of our a sub r plus a sub theta. We just found this to be -24, which it's squared, so that the negative will go away. Now we need to figure out our a sub theta, and a sub theta is r theta double dot plus 2 r dot theta dot squared. So this is a double dot, right? So Lorenzo, we're gonna be able to solve for this one.
I'm getting like really confused on the difference between theta double dot and a sub theta. Is theta double dot like in radians, like acceleration, then a sub theta is like just your standard meters per second squared. Percent squared.
Yes. Well, no, a sub theta won't be in meters per second squared,
Feet per second squared.
or feet per second squared. That's gonna be radians per second squared plus 2. Okay, so this is gonna be in feet. This is going to be radians per second squared. This is then feet per second, right, our r dot, and then this is then gonna be radians per second tire quantity squared.
But a sub theta is gonna be in feet per second squared.
I don't think so. That's why we're doing this. Except I end up with a second cubed over there. R dot, theta double dot's radians per second squared, right? R is gonna end up. Is R in feet?
Should be.
Yeah.
Yeah, R's in feet. Yes, R is the end result of R is gonna be in feet. Oh, wait, there's no theta squared here. We're fine. Square is up there. We're fine. So both of these end up being then feet radian per second squared. So
When you multiply those, that turns into just like,
we're not multiplying, we're adding them.
well, I was saying feet and radians.
Yeah,
Because when we do like velocity equals like radius times radians per second, then you just end up with per second. So I was just wondering if that canceled out kind of the same one.
yes, it's gonna cancel out the same way. All right, so we know a bunch of this information, don't we? A theta, we actually don't have to work that hard for it. We know that the R at 180 was 1. Theta double dot is what we're gonna look for, plus 2. R dot is 0. And then theta dot is 4, but that second term is gonna go away for me. So what do we end up with? We end up with 30 is then going to equal the square root of -24 squared plus theta double dot squared. That's because everything else went away. I'm gonna go ahead and square both sides. So we end up with 30 squared plus 24 squared equals theta double dot squared.
-24 squared.
I moved it to the other side.
Well, you square it and it's a positive number, but then you subtract it from the other side.
It's gonna become negative. All right. So theta double dot ends up being then 18 radians per second squared. All right, should we do 3:30? We're going to do one more of these. I wanted us to move to finish up chapter 12 today, but I don't think that's gonna happen. Should we do one more of these? Okay, all right. All right, let's do one that's very similar to your homework. This is 12-171. So go ahead and take a screenshot or write it down and let me know when we're good to go. So looking for an 8 in this chat. Okay. So I've got folks writing this down in class. Let me see if I can get you an answer. Okay. So Matt, if the theta double dot should be squared because of the way the equation worked out. So that's answer number one. Answer number two is you can either do your homework through Pearson, or you can do it paper and pencil. So you decide which way you're going to do it. This is not an actual homework problem. You would have to look in the schedule of work to see what the actual homework problem is. But yes, you should be doing homework and you should be uploading your homework. Are we good in the classroom? I still have some folks writing in the classroom. Is that correct? While they're writing, yeah, you can do it either way. Let's go ahead and get attendance taken care of. So I'm not back in attendance jail. I think I'm out of it now. All right. So here we go. Logan is here. Jaden is here. Melody is here. She's online. Max, are you still online?
Yeah, I'm here.
Atreyu is here. Skylar is here. Christopher is here. Gibran, are you here today? Okay, I'm gonna take that as a no. Valerie, you're here. Angelina, are you online? Okay. Anthony is in the classroom. All right, Musen, are you here today? Okay, Ally? Yeah, I got that recorded. I'm now looking for Ally. Devin, I believe you're here. Andrew, you're here. Amara? Amara's here. Brian? All right. Ray? Okay. Cheyenne?
I'm here.
All right. Martine? Lorenzo
Here.
is here. Okay. So let's go back to the problem. Let's work through this guy, see what we know, what we can find. All right, so we have a machine and the machine has a roller and it follows the surface of a cam. And it is described by this particular equation. So we know our equation for R. Our R equation is 0.3 plus 0.2 cosine of theta, and this time we are in meters. We are told theta dot is 0.5 radians per second. Theta double dot is 0. So my angular velocity is 0.5. My angular acceleration is 0. We want to determine the magnitude of the roller's velocity and acceleration when theta equals 30. Oh, and then we're going to determine its x and y coordinates. All right, so velocity, this is what we want. So this is what the problem is asking for. It wants to know the magnitude of the velocity. So that's going to be the square root of the velocity r term squared plus the velocity of the theta term squared. Okay, it also wants acceleration. Once again, square root of a sub r squared plus a sub theta squared. Okay, so let's figure out what we know, right? We know v sub r, correct? Maybe. So we know that v sub r, let's go after the velocity first. And get those two terms. All right. V sub r equals r dot. All right. So if we look at our r, and by the way, we are where? We are then when theta equals 30 degrees. So Lorenzo, that's our instant, is when theta equals 30 degrees. Okay. So r is then given to us as 0.3 plus 0.2 cosine of theta. So r dot, remember we're taking the derivative with respect to time, 0.3 is going to disappear for me. We're going to get negative 0.2 sine of theta, theta dot. All right, had to use chain rule on that. So if we put in sine of 30, help me out, is that 1/2? No, I don't think so. So we're gonna negative 0.2. What is it?
I think it's 1/2. That's 1/2.
Sine of 30, y'all have calculators. Check me.
I'm worried
It
about
is
my
1/2.
usage.
Oh, it is 1/2 times 0.5. 0.5 is the theta dot, not the sine of 30.
Sine of 30 is small.
Yeah. 0.05. So that's gonna be, yeah, that makes sense, because that's gonna be 20 divided by 4. All right. So let's go ahead now and find our V sub theta, which is then going to be R theta dot. So now we need to plug it into our original R, that 30 degrees. So let's figure out what that is. That's going to be 0.3 plus 0.2 cosine of 30 degrees. I know that square root of 3 over 2, but give me a decimal. The author seems to think it's 0.47. What did you get, Skylar? Oh, you're like, no. Virtual folks, anyone get 0.47?
I got 0.47.
What?
I got 0.47.
Okay, so Skylar said she got it. All right, so this becomes 0.473, at least that's what the author got. All right, and so our theta dot, it was 1/2, correct? Yes.
Yes.
So our V sub theta is then going to be 0.473 times 0.5. It's gonna cut that sucker in half. So 2, 3, 7.
Yeah.
Okay. All right, so V is then going to be the square root of negative 0.05 squared plus 0.237 squared.
At 0.2448.
Let's round it. 242. So that was one of the answers we were looking for, right? That's our total velocity. All right, now let's go ahead and find our acceleration. So we're going to go after the acceleration now. What do we know about the acceleration? We know that that's going to then be the square root of a sub r squared plus a sub theta squared. All right. A sub r is then r double dot minus r theta double dot, or wait, no, it's only one dot, right?
Yeah.
Theta dot squared.
Single dot.
Okay. All right, so what have we found? Well, we're given theta dot, we're given that to be 0.5. We know R is 427? 473. Okay, all right, so we need to find R double dot. So our R dot equals 0.2 sine of theta dot. R double dot, all right, is then going to be, we're gonna have negative 0.2 or that's gonna become a cosine, isn't it?
Yeah.
Cosine of theta dot times theta dot. right? So this is my first, that's the derivative of my first. Then we'll do the derivative of the second, 0.2 sine of theta, theta double dot. Theta double dot is going to be 0. So this term is nicely going to go to 0 for us. So we're going to have negative 0.2 cosine of 30 degrees. And then we already found our, oh, we're given theta dot. So that's going to be 0.5 times 0.5. And so I'm seeing negative 0.0433. Did anyone else get that?
Yeah, I got that.
Oh, yeah, negative.
All right. Cool. So let's figure out what our A sub R is. Right, our A sub R is going to be negative 0.0433.
Wasn't that? Oh, never mind.
We okay?
Yeah, I made a mistake.
Okay, minus, and then we 0.473. All right, and then we have our theta dot squared, so that's going to be 0.5 squared. So what we end up with A sub R is 162. Okay, so I got a yes in the classroom. This is my A sub R, right? So this is 1 that I'm going to have to put into that square root term. Let's now go ahead and find our A sub theta. So that's R theta double dot plus 2 R dot theta dot. First term very nicely goes to 0 for us. So then we're going to have 2. We already found our R dot, right? That was negative 0.05. And our theta dot is 0.5. So those two are going to cancel. Negative 0.05 is what we're going to end up with here. Now I have this in the meters per second squared. All right. So let's figure out what is going on with our A value. So that's then going to be the square root of A sub R 0.162 squared plus negative 0.5 squared. 0.169. All right, so then it wants us to find what? Now that we're at this point, so we found our A and we found our V, the instructions say to us to go in and find the velocity components, VAX and VAY, of the roller at this entrance, at this instant. All right, and so that's the sine and cosine information that I had up on the board. All right, and in fact, because I think there should be an R in there. Oh, my computer went blank. the unit vector doesn't have an R. But I think our conversion needs to have an R in it. Okay, so let's get them into the other components. Guys, double check this equation to move between them. Five cosine 30 plus 0.237, which is v sub theta. All right, so my BA in the x direction is then going to be, I believe it's VR. Who's got the book up? I only have the
It would
numbers.
just be V times like cosine theta,
Yeah, because we already got V.
because V is just a vector at a 30-degree angle, right? No, I'm wrong. I'm wrong. It's a different angle.
They can be easiest to,
It
just
is?
like Drew's we probably
But
got
that's
They have
this
the
angle,
V
but
theta,
V
VR.
is, that's like, solving it that different direction.
All right, so we're gonna end up then our V sub Y. Is gonna be here and our VAX. Ends up being there.
And we know our,
So it's the tangent at that point, right? That would be the V vector?
Yeah, the V vector would be the tangent.
I thought that would be the V theta vector. VR should be normal, V theta should be tangent.
Well, yeah, VR is here. Okay, and then V. Well, V theta. V theta is then going around, so I'm assuming V theta has to be there.
Know that angle that it makes with the Cartesian plane. So we've got, our theta is 30.
Right. But I believe there's a, let me look at your textbook real quick. Thought there was a collaboration between the two of them. I'm not seeing it. All right, so this is what they have. So they have 0.5, which we found as our R dot. Right, and somehow it lost a sign. So negative R dot cosine theta plus, that's in the I direction. Oh, okay, and then that is then going to be plus R yeah, R theta dot sine of theta. That's in the J direction. So, and that has to do with the relationship between polar and rectangular coordinates.
The U vector, the UR equal in U theta that you talked about earlier, or?
Yes. So X is R cosine theta, Y is R sine theta. Okay, so if we go back to our polar coordinates, X equals R cosine theta, Y equals R sine of theta. That's the relationship between them, but it looks to me like it's gonna be, we're dealing with V, then that's gonna be R theta dot, right? This is the straight XY coordinate system. All right, so negative of negative 0.05 cosine of 30 degrees plus, and then that one, the V sub theta was 0.27, correct? 237.
Yeah.
Sine of 30 degrees. Making sure that makes sense. All right. So we end up with 0.162 meters per second. All right, and then we're gonna do the same thing with the for it in the y direction. We're gonna have to flip them. So this is VAX. Right? VAY. That one is then. Oh, it's already negative. R dot sine of theta. All right, and then we're gonna have plus R theta dot cosine theta. So those two are gonna split 0.05 becomes positive sine of 30 degrees. And then we're gonna have 0.237 cosine of 30 degrees. And we end up with 0.180. Okay. Let's take a little quiz on this. Trying to figure out what that exact, so I will post the exact equation in the announcements, but let's take a quiz on this on Wednesday, so try to do some homework. I'm gonna be much more interested in you figuring out V sub R and A sub R than anything else, because that's the course objective. Yes.
It was coincidence that V sub X and A sub R are the same, right?
Yes.
I mean, the units are different, but the values,
Yeah, that's a coincidence.
okay.
All right. So I will see you all Wednesday. As I said, plan, or would you prefer, because we didn't do any group work today, would you prefer a group quiz or a proctored quiz on Wednesday?
We haven't quite said a real question.
Yeah, it's a real question. Do you want to group work on Wednesday or a proctored quiz?
Group.
Group work. Perfect. That's what I wanted to know. All right. So you all are dismissed. I will see you all on Wednesday. There is a pre-class quiz for chapter 13 up here.
I didn't, how you got these. So AX and some UI.
That made two of us.
Okay. All right.
So I'll put together something. And
Oh, is that what you were saying? Okay.